Today we are going to learn how to balance chemical equations. At least this is one thing all chemists should be able to do, because an equation that's not balanced is not an equation. So let us take an example of reactant A combining with B. Let us set its diatomic to form a product AB. So the rules of a chemical equation will tell you that the left hand side of the arrow, if we are to divide this, or the left hand side of the equation, the reactant side, then we also have the product side. So the atoms on the left hand side, atoms of element A and atoms of element B, must be equal to their corresponding atoms on the right. So that means if you look at our left hand side for the reactants, in this case we have A has one atom, element A has only one atom. However, under the reactant side still, element B has two atoms because of these two here. But when we go to our right hand side, it is true A has one atom because we have an invisible one between A and B, and then B has one atom. We have an invisible one after B. So if you are to look at this, it means that in our reaction we had one atom of A combining with two atoms of B, but under the product side we have one atom of B. This is not possible because we know that matter is neither created nor destroyed. So if you had two atoms of B, we need to see two atoms of B on the right hand side of the arrow. So in this case this equation will not be balanced, and as such we have to work towards balancing it. Let us now try balancing some equations. When you look at this equation, we have magnesium reacting with nitrogen gas to form magnesium nitride. So we have our left hand side and we have our right hand side. So we need to start comparing the number of atoms of the corresponding elements on both sides. We shall start with magnesium. Magnesium actually has one atom on the left hand side. However, on the right hand side, magnesium has three atoms. We have a 3 here. So these are 3 atoms of magnesium. When you look at nitrogen on our left hand side, we have 2 atoms of nitrogen. However, on our right hand side, it's 2. On our right hand side, we also have 2 atoms of nitrogen. So what does this mean? It means that nitrogen atoms are balanced. However, the atoms of magnesium are not balanced. You can't start with 1 atom and end up having 3 atoms of magnesium. So what does that mean? It means you must have at least more atoms of magnesium for you to have 3 atoms of magnesium on the right hand side. So for that case, we shall need to multiply the atoms on the left hand side for magnesium by 3. So we need to multiply these ones by 3 so that they become 3. How do we do that? By bringing 2 more atoms of magnesium. So we shall put a 3 in front of magnesium to show that we have 3 atoms of magnesium. Remember, if you have 1 atom of magnesium, you have another atom of magnesium and another atom of magnesium. If you have to add these ones, actually we can write them as 3 magnesium atoms. Just like you might have A plus A. A plus A is 2A. So we can't write it as A2, so it's better we write it as 2A. So we shall put a 3 in front of magnesium to show that we actually need 3 atoms of magnesium so that we can have 3 atoms of magnesium on our right hand side. So in this case, we shall be having 3 atoms of magnesium on the left hand side with 3 on the right hand side. And our nitrogen will also have 2 atoms to 2. So in this case, all atoms are equal in terms of numbers. And in that case, our equation will now be balanced by placing a 3 before magnesium. Let's now look at another equation. And this equation, we are having hydrogen reacting with oxygen to form water. So we shall have our left hand side and our right hand side. So on our left hand side, we have hydrogen atoms and oxygen atoms. So we have 2 atoms of hydrogen. Our right hand side, we also have 2 atoms of hydrogen in the molecule of water. On our left hand side, we have 2 atoms of oxygen because oxygen gas is diatomic. On our right hand side, we have 1 atom of oxygen. So this shows that actually hydrogen is balanced 2 to 2, meaning no loss of atoms or gain of atoms. However, on our oxygen part, we have 2 atoms of oxygen at the start, but we have 1 atom of oxygen under the right hand side. So what does that mean? Could it mean 1 oxygen atom was lost? Since we can't lose atoms, we have to find a way of balancing the oxygen on our right hand side. And we can do that by trying to increase the number of water molecules, because it's water which we are producing on the right hand side. So currently we have 1 molecule of water. So if we are to get another molecule of water and the second one, if we have 2, that means we shall have 2 water. And what does this mean? It means we have 2 atoms of oxygen. We have this one, and we have this second one, 2. These are the 2 atoms of oxygen. So if we write it like this, it basically means that these 2 will be showing us that we have 2 atoms of oxygen. So in the due process, if I place here a 2 on water, it means now my oxygen will be containing 2 atoms. And at that point, we shall have equal number of oxygen atoms on the left and equal number of oxygen atoms on the right. But in the due process, as we change the number of water molecules to 2, our hydrogen changes. So instead of having 2, we now actually have 4. So again, we have a problem, because initially our hydrogen was balanced, but now it's no longer balanced. We have a 2, and this side we have a 4. So what can we do? We have to increase whatever substance containing hydrogen on the left hand side, and that substance is hydrogen. So we shall have to bring another molecule of hydrogen, so that if we have 2 molecules of hydrogen, we shall now be having 4 hydrogen atoms. So we have to put here 2, so that now our hydrogen atoms also become 4. So 4 hydrogen atoms on the left hand side and 4 hydrogen atoms on the right, 2 oxygen atoms on the left hand side and 2 oxygen atoms on the right. So the equation will be balanced by placing a 2 in front of hydrogen and a 2 in front of water. So for this case, we shall now say this equation is balanced. So we basically vary the number of molecules either on the left hand side or the right hand side of the arrow. In this equation, we are going to try balancing the reaction between sodium peroxide with water to form oxygen gas and sodium hydroxide solution. So as usual, we shall have our left hand side and our right hand side. But some tip, the method I'm going to use is I'll have to use some fraction to simplify my balancing in this case. And the hint is I'll have to balance the element that is alone. So in this equation, you find that the only element that is alone is oxygen. So I'll have to balance oxygen atoms last, because in that case I can use a fraction to balance out the whole equation with ease. So we shall start with our sodium on the left hand side, then hydrogen, and then lastly oxygen atoms. The same applies to the right hand side. We have our sodium, hydrogen, and then oxygen atoms. So let's look at our left hand side. We have 2 atoms of sodium. On our right hand side we have 1 atom of sodium. So sodium is actually not balanced, because that means 1 atom of sodium disappeared. We started with 2, now we have 1. So I'll have to bring in another molecule of sodium hydroxide so that I can balance the sodium to be 2. What do I mean by that? Our product side, we have sodium hydroxide. If I can bring in another molecule of sodium hydroxide, I'll now be having 2 molecules of sodium hydroxide. But in the due process, I'll be having 2 atoms of sodium. So in that case, my sodium can become 2 if I place a 2 in front of sodium hydroxide. So the 1 atom is this sodium atom, and the second one is that sodium atom. Those are the 2 atoms of sodium. So sodium is now balanced. I'll now go to hydrogen. Hydrogen, we have 2 atoms on the left hand side of the arrow, and then we have 2 atoms of hydrogen on the right hand side. Hope you can see them. 2 atoms of hydrogen. This is the first atom and this is the second atom. So we have 2 atoms because we have placed a 2 in front of sodium hydroxide. If at all you are using a piece of paper, you can first use a pencil in this case. So we have 2 hydrogen atoms. So lucky enough, hydrogen is balanced, 2-2. So now we go to the last one, which is oxygen. Oxygen, we have 2 atoms from sodium peroxide plus 1 atom from water. So that makes a total of 3 atoms on our left hand side. When we come to our right hand side, we have the 2 atoms of oxygen from sodium hydroxide plus the 2 atoms of oxygen from oxygen. So now here I have a total of 4, but I would like it to be 3. Although also they said I would like it to be 4, but because I want to balance this oxygen last, I'll have to find a way of making this one 3. So how is that possible? I'll have to ensure that I put a certain fraction in front of oxygen, and this 2 is coming from our oxygen molecule. So what can I multiply by this so that when I add it to 2, I get 3? So I have to find a way of making this 2 a 1. So I'll have to multiply this by a half. So don't get lost. So in this case, I'll have 2 plus 1, because 2 times a half is 1. So if I can somehow have an invisible 1 here, I'll be having the 2 oxygen atoms in sodium hydroxide plus the 1 oxygen atom. So I'll have 3. So after finishing all that, I'll now have to remove the denominator, these 2 here. So let me rewrite this equation and we see what exactly we are having currently. So currently we are having sodium hydroxide with our water forming the 2 sodium hydroxide, if at all you had used a pencil, plus a half oxygen gas. So this is how it is balanced currently, but it's not good to balance with fractions. So I'll have to ensure that I eliminate the fraction, or the denominator and the fraction. So I'll have to multiply throughout by 2. So a half times 2, sodium hydroxide times 2, water times 2, sodium peroxide times 2. So 2 times 2 is a 2. So let me write now our final balanced equation. I'll put here 2. 2 times 1 is a 2. 2 times 2 will be a 4. And then 2 times a half will be 1. So even if I don't write it. Now, we are only left with checking whether our equation is balanced. So let's go through it again. So sodium, we have 2 times 2. Let me hope you can see it. This 2 times 2, that is 4. So sodium, we have 4 atoms of sodium. Oxygen, we have 2 times 2, that is 4, plus 2 times 1, so that will be a total of 6 oxygen atoms. So let's cross out here, we have 6 oxygen atoms. On our right hand side, sodium we have 4, oxygen we have 4 plus 2, which is 6. Okay, that's oxygen. Here 6, we shall cross all this, we have 6, not hydrogen, we shall rectify this. Then hydrogen we have here 4, 2 times 2, this is a 4, while we have here 4 times 1, which is a 4. So you can see that actually our equation is balanced. Why? Because we have 4 sodium atoms on the left hand side, 4 on the right hand side. We have 4 hydrogen atoms on the left hand side, and we have 4 hydrogen atoms on the right hand side, and then 6 oxygen, 6. So the number of atoms of each kind of element on the right hand side is equal to the number of atoms of that same element on the right hand side. So we shall say our equation is balanced by placing a 2, a 2, and a 4 as seen. Yeah, this is quite challenging, but with time it is easy to balance. For this one, you can feel free to try and attempt it first. You can pause the video, but let's try it out and see how different it is from the other equations. So we shall start with our left hand side. We have lead nitrate decomposing on heating to form lead oxide with oxygen and nitrogen dioxide, and then we have our right hand side. So the elements we have lead, we have nitrogen and oxygen. So we have to ensure that the atoms of all these elements are equal on the left hand side and the right hand side, because we can't destroy atoms, we can't create more, so they have to be equal. So still my trick will be to balance oxygen last. If at all you are not used to this kind of method of using fractions, it's fine to use your other method, but to me it works wonders. So when you look at the left hand side, we have lead, we have 1 atom of lead. Right hand side we also have 1. So lead is balanced. We go to nitrogen. Nitrogen we have 2 atoms because of the brackets. This 2 also works for nitrogen, so we have 2. Right hand side we have 1. So we should try and ensure that we get 2 atoms of nitrogen. And for that to happen, we have to bring in another molecule that contains nitrogen, and in this case it is nitrogen dioxide. So let's try to have 2 nitrogen dioxide molecules. So we shall put a 2 in front of nitrogen dioxide with our pencil, and with that we shall now be having 2 atoms of nitrogen, and in this case nitrogen will also be balanced. So we are left with oxygen. Oxygen on the left hand side we have 3, but 2 times, that is 6. Right hand side we have 1 plus 4, that is 5, plus 2, that is 7. But let me write it like this. We have the 1 from lead oxide, we have the 4 from nitrogen dioxide, and we have the 2 from our oxygen molecule. So we want the oxygen atoms to be 6 or to be equal to 7, but because I want to use this oxygen molecule as my basis to balance with my fraction, I'll have to ensure that I have 1 plus 4, that is 5. What do you add on 5 to get 6? So I'll need a 1 from this oxygen molecule. So I have to ensure that I multiply it by a certain fraction so that I can get 6. Let me repeat what I'm trying to imply here. We have 6 oxygen atoms. This side we have 7, but I would like it to be 6. However, I can't change the oxygen atoms in lead and nitrogen dioxide. The best I can do is to change those from the oxygen molecule, this one here. So if I can multiply this by a fraction like a half, I'll then be having 1 plus 4, that is 5, plus 1, because 2 times a half is 1. Then I'll have 6, it will have balanced. And at that point I'll have the following equation. I'll have lead nitrate forming lead oxide plus the 2 nitrogen dioxide plus a half the oxygen molecule. So at this point it will be balanced, but like I said, it's not good to balance with fractions, so we shall have to eliminate the denominator, these 2, by multiplying all throughout by 2. So a half times 2, 2 times 2, 2 times 1, and 2 times 1. So if we are to simplify this as we balance our original equation, we shall have a 2 here, we shall have a 2 here, a 4, 2 times 2 is 4, and then 2 times a half is 1, so I'll not write the 1. So let us now check and see whether our equation is balanced. At this point, shall have lead, it is 2. On our right hand side also lead equals 2. So 2 equals 2, that is balanced. So as you can see, the fraction somehow balances our equations instantly. We go to nitrogen, so let us try and follow through. So initially we had nitrogen, we had 2, but now with this 2 we shall have nitrogen 4. So nitrogen equals 4. This side we have our 4 already here, nitrogen equals 4. So nitrogen 4 equals 4. It is balanced, so I believe you can all see how this magic is working out for us. Then lastly we have oxygen. Oxygen initially we had 6 times now this 2, that will be 12. On our right hand side we have 2, so let us write it here, 2 plus 4 times 2, this is 8, 2 plus 8, then plus 2 here. So 2 plus 8 plus 2, that is 12. So you'll find out that even here our oxygen is now equal to 12, 12, 12. So the equation becomes balanced because lead 2, 2, nitrogen 4, 4, and oxygen 12, 12. Like I said, it takes some practice for you to realize that actually balancing such equations will be easy and fun. So this is going to be our last equation. Feel free to pause the video and try it out before I do so. We shall start with our left hand side and then right hand side. So you don't need to do all this working. If at all you can do it in your mind, it's fine still. So we have nitrogen reacting with oxygen to form, ammonia reacting with oxygen to form nitrogen and water. So left hand side we have our nitrogen, hydrogen and oxygen. This side we have the same atoms, nitrogen, hydrogen and oxygen. Still I'll either balance oxygen or nitrogen last, but I'll go for oxygen. So I'll try to balance oxygen last with my fraction, and then as I remove the denominator, my equation will get balanced. So let us start. Nitrogen, we have one atom because we have an invisible one between N and hydrogen, so it's 1. Here nitrogen is diatomic, we have 2 atoms of nitrogen. So you can't start with 1 atom of nitrogen and then have 2 atoms of nitrogen on the right hand side. So that means we shall have to increase the number of molecules containing nitrogen on our left hand side, and these are the ammonia molecules. So we must have at least 2 ammonia molecules so that our nitrogen is balanced. So we shall put an invisible 2 with our pencil in front of ammonia. So at this point our nitrogen will now be equal to 2. So 2 is equal to 2, nitrogen will be balanced. So we go to hydrogen. Hydrogen, we now have 3 plus 3, which is 6, or we can say 2 times 3, which is 6. So hydrogen, we have 6 on the left hand side because we added a 2 on ammonia, but on the right hand side we have actually 2 atoms. So how can I have 6 atoms of hydrogen on the right hand side? Because in the reactants we have 6. So for that to happen, instead of having 1 water molecule, I think I will need 3 water molecules on my right hand side. So in this case we shall have 3 water molecules. 2 plus 2, 4 plus 2, 6. So I'll put an invisible 3 on my water molecule. And in the due process, I'll be having 6 hydrogen atoms. So in that case, our hydrogen is also balanced. So I'm now left with only oxygen. So now oxygen, on our left hand side, we have 2 atoms. But on our right hand side, we have 3. Let me hope you can all see the 3 oxygen atoms. This is 1, this is 2, and that is 3. Or we can see it from this directly, 3 oxygen atoms. So I need to make my oxygen atoms 3 on my left hand side for it to balance. So now this is where my fraction comes in. What do you multiply by 2 to get 3? Obviously it will be 3 over 2. That will be my fraction. So with this fraction, I'll be able to have 3 oxygen atoms on the left hand side, so that will also have 3 on the right hand side. Let us see my current equation, how it looks like. I have 2 ammonia plus 3 over 2 oxygen forming nitrogen plus 3 water. This is how my balanced equation looks like, although I'm balancing with a fraction. So I have to ensure that I remove the denominator, these 2, by multiplying throughout by 2. So I'll multiply this by 2, this by 2, this by 2, and the last one by 2. So 2 times 2, that is a 4. So I'll put here my 4. 2 times 3 over 2, that's a 3. I'll put here my 3. 2 times 1 on nitrogen, that's a 2. And then 2 times 3, that is a 6. So now my equation will be balanced. But we obviously have to check and see whether our theory is still working. So let us see whether the equation is actually balanced. Nitrogen we have 4. So I'll cross out my 2. Now we have new atoms. We have 4. On our right hand side, 2 times 2, it is 4. Yeah, nitrogen is balanced, 4, 4. We go to oxygen. Oxygen, 3 times 2, 6. Okay, I've skipped hydrogen, but no problem. So we now have 6. On our right hand side, 6 is already shown here. 6 water molecules, so 6 oxygen atoms. So this is also 6. So as you can see, my equation is actually balancing out on its own. I don't know how. And then lastly, we have hydrogen. 4 times 3, that is 12. So here we have 12. And then we have 6 times 2, which is 12. So all atoms, nitrogen 4 to 4, hydrogen 12 to 12, and oxygen 6 to 6. And that is balancing chemical equations. Feel free to let me know which equation you would like to see how it is balanced, but this is the basics, and please do try some practice questions, and then I believe with time it will be easy. Thanks for watching. Those who are new on this channel, don't forget to subscribe, like, comment, so that whenever I upload new content, at least if you are subscribed, you will be always notified. Be well.